Okay, are we ready? Oops, I forgot calculator. Okay, take a look at your top section here. We're not going to do all of these. We're just going to do a couple of them just to kind of make sure that you're able to get started. So you have your common base chart there at the top. Okay, any log that doesn't have a listed base, do you remember what it is? It is 10. Very good. So if you want to fill in the blank here, any logs without a base are considered base 10. And then what do I do on the exponent if it's in a fraction? Do you remember? Huh? Negative. Very good. You're going to use a negative on any exponent that needs to be brought up from the denominator of a fraction. Okay? So we're just going to run through a couple of these, then we'll turn the page, do a couple off the next page, and then I'll give you guys some time to work. So let's start off with, let's do number 3. Okay, first question. You have a 9 on one side and a 3 on the other. So remember, we're going to use common bases to try to convert the 9 to match the 3. What is 9 as a base 3? What is 9 as a base 3? 3 squared, very good. So it's going to be 3 squared, and then leave your x behind in parentheses. Because remember, that x was already there. Okay, then on the other side, I have a 1 over 3 to the x minus 5. So that's a 3 to the 1. It's already a 3. The problem is it's a 3 on the bottom. So how did we say we pull it up? Make it negative. So you'll have 3 to the 2x, 3 to the negative 1. And then what do I do with the old x minus 5? Parentheses. Very good. Okay. Then from there, now that we have common bases, we're going to cross those out. So my 3's are gone. And I have 2x equals, what do I need to make sure that I do on the right-hand side? Distribute. So that'd be a negative 1x and what? Plus 5 or positive 5. From there with my minus 1, we want to add that across. So what's 2x plus 1x? 2x plus 1x would be 3x. And then if 3x equals 5, my last step would be to divide by 3. So my answer for that one would be x equals 5/3. Questions on that? Okay. Next one, let's do number 5, please. Number 5, how do I get rid of a log little 4 or a log base 4? We do a big 4. So big 4, big 4. And then remember, log little 4 and big 4, I'm going to cross out. And I'm going to have 1 over 8 equals 4 to the x minus 1. Okay, then from here, I want you to look in the forwards chart and try to find 8. Do you see it? Okay, you have your chart on your desk? No. And if I can't turn 8 into a 4 chart, then what can they both match in the 2's chart? So remember, if you can't just fix one side, you can always fix both. So look in your 2's chart. What is 8 as a base 2? 2 to the what? And if it's a fraction, what would I write? 2 to the negative 3. Versus for my 4, what is that as a base 2? To what? To the 2 or squared. Old exponent, just keep it in parentheses. Okay? Then from there, we have our matching 2's, so we can go ahead and cross those out. So I have negative 3 equals. Make sure you distribute the 2. I'm going to write the x on the left-hand side, but that's really up to you if you like that better. So it'd be 2x minus 2 equals negative 3. Okay, so I just kind of flip-flop those. What do I do with the -2? Okay, plus it across. -3 plus 2 gives me 2x equals -1. And then from there, divide by 2. So x would equal -1/2. Okay. Next one, let's do number 9, please. How do I get rid of a log little 64? What do we do on both sides? Big 64. So 64, little 64 crossed out. I have 2x equals 64 to the 1/2. Okay, from there, you should notice something very important. Your x is not little anymore. That's a regular x. And if that's a regular x, I want to turn this side back into a regular number as well. What is a 1/2 power the same as? Very good. So I'm going to cross out the 1/2 and turn it into a square root. And then what is the square root of 64? What number? 8. And then if 2x equals 8, then divide by 2 on both sides, x equals what? 4. Very good. Okay. Maybe last one we'll do off the front's number 8. How do I get rid of a log little 2 on number 8? Okay, put a big 2 on both sides. So because I kind of wrote too big, I'm gonna like section off this question. And I'm gonna write in a different color. So we're gonna big 2 on both sides. So I have big 2 and log little 2 crossed out. X equals 2 to the -5. Okay, question. Is this a little x or a regular x? Regular x. And I want this to go back to being a regular number, not an exponent. What is 2 to the 5? Look in your chart, please. 32. Then if it's 2 to the -5, what would it be? 1/32. Okay, so remember, why is it a fraction? Because of the negative, but we're turning it back into a regular number because your x is a regular x. Okay, also little fun fact for your test, you can just type this into the calculator and it'll tell you. So the chart is kind of like a shortcut to help you, but you can also use the calculator for those. All right, go ahead and turn the page when you're ready, please. Okay, we have quite a few more solvings to run through. Next page, let's do number 10. Okay, take a look at number 10. What do you guess we should do first? +1. Why can't I get rid of the log right now? Because if there's something outside of the log, that's got to go first. So add that 1 across. What is 1 + 1 over there? So I have log 2x minus 20 equals 2. Okay, then I notice my base is missing. If the base isn't listed, what is it? 10. And how do I get rid of a log little 10? Big 10. So my big base 10 and my log base 10 crossed out. 2x minus 20 equals 10 squared. Is your x a little x in an exponent or a regular x? Regular, then I want my other side to be regular as well. So 10 squared, you can look it up in the chart or put it in the calculator if you like that better. Okay, what is 10 squared the same as? 100. And then from there, what's our next step? Add the, yep. So 100 plus 20 is going to be 120. And then divide by 2 on both sides. Final answer would be what? 60. Very good. Okay, next one. We'll do maybe 2 more off this page. Let's do number 14. Okay, number 14, what you should notice is that you have logs and you have them kind of all over the place. So the first thing I want to do is get rid of the numbers in front of the logs. What do I do with a number in front of a log? Do you remember? What can happen to a number in the front of a log? Can we move it? Move it up to an exponent, that's right. So this is now going to be log x equals log 64 with a half on it minus log 27 with a third on it. Log 64 with a half exponent, and then log 27 with a third exponent. But remember, both of those exponents are actually roots. What is a 1/2 going to turn into? Square root. And what about a 1/3? Cubic root. Okay. So then from there, I have log x equals. Do we know what the square root of 64 is? 8. And do we know what the cubic root of 27 is? It is 3. Let me show you though how to put it in the calculator. Okay, if you don't know where the cubic root is, let me just show you. You're going to hit the math button right here. And then do you see that you have an option for cubic root? So I don't expect you necessarily to have those memorized, but for 27, okay, we should know it's 3. So that'd be log 8 minus log 3. Question, can I right now log both sides? If there's more than one on the right side. You gotta condense, right? And if the logs are subtracted, how can I put them into one log together? Do you remember? Divide. So it'll be log x equals 8 won't divide evenly by 3, so I'm just gonna put 8 over 3. And then from there, what's the base if it's not listed? 10. So I'm gonna put a little 10 here and a little 10 here. And then how do I get rid of a log little 10? What do I use on both sides? Then my 10 and my log little 10 cross out. My 10 and my little 10 cross out. X equals 8/3. You look stupid. Okay, all good with that? Okay. Last one we'll do off this page. Take a look at number 15. Number 15, you have 2 logs and they are added. What do we need to do if our logs are added and we need to condense them? We're going to take this, and we're going to multiply. You're exactly right. Now, real quick, normally these are like really easy things that I could be like, what's 5 times 2x? And you just do it. Okay, but because it's an x minus 4 times an x plus 4, I'm going to actually multiply that out to the side. So I have x minus 4 times x plus 4. So x times x, or we're foiling this if you like that better. What would we get there? What about x times plus 4? 4x. Negative 4 times x would be negative 4x. And then last one, negative 4 times 4, what we get there? Negative 16. Then from there, what will happen with those middle 2? Cross them out. Because if it's 4x and negative 4x, those are now gone. So I'm just going to keep the x squared and the minus 16. So when I multiplied those, this is what I got. But remember, the point of that is that I'm taking those 2 logs that are added and I'm squishing them together into the same log. So we're going to have log little 4, x squared minus 16 equals. And then on the other side, I notice I have a 2 in front of my log. I don't want that. So how can I get rid of it? Where can I move it? can turn to a exponent, right? So I'm gonna have log little 4 of 3 up to the 2. What is 3 up to the 2 the same as? 9, correct. And then from there, I noticed that I have a log on both sides. How convenient. How do I get rid of a log little 4? Big 4. So I'll do a big 4 on both sides. 4 and log little 4 cross out. I have x squared minus 16 equals 4 log little 4 cross out, 9. What do we do from there? Plus that 16 across, very good. 9 plus 16 gives us what? And then from there, how do we get rid of this word? Square root. So x equals plus or minus 5. Also make sure if you're solving a quadratic, an x squared, you should get 2 answers. If it was a cubic, you should get 3 answers. Okay, versus like on this one up here, on number 10, if I have only one x, I should only get 1 answer. Okay, so the power on x should tell you how many final answers you're getting. Okay. All right, then on number 16, if you want to make a note to yourself, you're going to end up T-charting at the end of that one. So if we need to go over it in a little bit, we can. But for now, I'm going to give you like 10 minutes. Just kind of work together, make sure you kind of remember stuff. And then Mr. Gillen, if you'd pause the video for 6, just let him work for about 10 minutes and then keep playing the video in like maybe 10 minutes-ish. Okay, go ahead and finish up the one you're working on, please. Yes. Okay, we're gonna start on that next page. You need a calculator for the next page. Remember when you put your numbers, that's it'll be an x plus 2 and an x minus 1. And then remember your answers are just the reverse of the numbers. Oh, so the x equals -2 and x equals
Oh, that's right.
Okay, are we ready? Okay, take a look at your next page, please. Pretty please. Okay, go ahead and let's look at number 20. Okay. Number 20, please. What do you think we should get rid of first? Right here. Okay, there's a -9. How do we get rid of it? Okay, +9. So 2 plus 9, what's the number on the other side now? 1/3, 6, x plus 3 equals 2 plus 9 is 11. From there, how do I get rid of a 1/3 or divide by 3? What do we do? Multiply by 3. What is 11 times 3 on the other side? So I have x plus 3 on the 6 equals 33. From here, if this were on the note calculator section, you would look in the 6's chart for 33. Okay, if you want to check, go ahead and do it. Okay, my 6's chart. Okay, I see that I could have gotten 36, but I can't get 33. That's not an option. So this is where you'll need a calculator. How do I get rid of a big 6 as the base? I do a what? Log, not e, log little 6. Remember? And if I log little 6 on the right side, then I need to do it on the left side as well. So from here, my big 6 and my little 6 are going to cross out. My x plus 3 is going to come down. And then for this side, if you remember, you're gonna put that in the calculator. The steps for that are on the top right-hand corner of your paper. Okay, so let me draw your attention right here. You're gonna push alpha, window, and then log base. Okay? So to get rid of a big 6, we're gonna log little 6, which is alpha, window 5. And then remember, all these are pretty much gonna come out as decimals. So let me show you on here. Alpha window, option 5 is log base, little 6, big 33 in the other box. Comes out to 1.95. You're gonna go to 2 decimals for your test. 1.95. From there, what's my next step? Minus the 3, very good. And 1.95 take away 3 gives me negative 1.04 followed by an 8. How would I round the 1.04? Keep it or bump it? Okay. So it'd be negative 1.05. Okay. And you're gonna go to the hundredths for this whole page. Let's do the one right next to it. Some of us struggled a little bit with number 6 on the front page. So this one's a little bit similar. What do I do if my base is a root 3? What is a square root the same as? So this is really a 3 to the half of 6x minus 10. That's really a 3 to the half of 6x minus 10. And then on the other side, for my 81, what is 81 as a base 3? Look in your chart. 3 to the 4. Now, what if it's an 81 on the bottom? Very good, negative. Okay. Then from there, what do I do with those 3's on both sides? What do we do with the 3's on both sides? Okay, thank you. And then I have half of 6x minus 10 equals negative 4x minus 4. So let's go ahead and pull those numbers in from the outside. What is half of 6x? 3. Okay, 3x. What about half of negative 10? Negative 5. On the other side, negative 4 times x is negative 4x. Negative 4 times negative 4 is plus 16. Okay, from there, we have x's on both sides. We should know how to solve this, but in case we've forgotten, you got to pick one of your x's to move across to be with the other x's. So I'm going to get rid of the minus 4x. How am I going to do it? Plus 4x. 3x plus 4x is how many? 7x minus 5. What do we do next? With the minus 5? Yep, plus it across. 16 plus 5 is how many? So I have 7x equals 21. And then last step, divide by 7. And our x is 3. Okay, now I'm realizing I kind of made this review in a rush. What section does that really fit in? Not really here, more in the common basis, right? Okay. So oopsie, my bad. Okay, let's do one more from this section where it's not an E. Let's do number 22 right next to it. We'll just knock out this row. Can I log little 4 right now? No, what's in the front that has to go? The 5, and it's a multiply by 5. How do we undo multiply by 5? Divide. So I have 4 to the x minus 2. 50 divided by 5 gives me what? 10. And then I would say, okay, let me go to my fourth chart and let me look for 10. Okay, this time you'll notice it's not there. So how do I get rid of a big 4 as a base? What do I do? How do we get rid of a big 4? Log what? Little 4. And that's where you're gonna use that button that I showed you. Okay, so your x minus 2 comes down, and then you're gonna figure out what this is in the calculator. So remember the steps for that are alpha window and then option 5. So I want a little 4 in the small box, a 10 in the big box. I got 1.66. Final step, how do we get rid of the minus 2? Okay, plus 2. And 1.66 plus 2 gives me 3.66. Okay. Next one I'd like to do is number 24 in the row right below that. Number 24. What are we going to do with this number in the front here? Divide. So divide by 25 on both sides. What is 100 divided by 25? Okay, that's going to give me e to the x over 2 minus 1 equals 4. Okay, at this point, we just covered this last class, and e is just another number. It's on your calculator. How do I get rid of a big E? I need to use a log little e, which is the same as a what? Natural log. So I'm gonna ln and ln. If you weren't here last time, okay, make sure you go back and watch those notes. But an ln is a shortcut for a log little e. Your ln and your e are gonna cross out because they're partners, they're inverses. So my x over 2 minus 1 equals, and then do you remember that you have a shortcut for the ln button? It's down here in the corner. Your ln is right here. So we're going to find what the ln of 4 is. Okay. So the ln of 4 gives me 1.38 followed by a 6. Keep it or bump it. 1.38 is going to bump to 1.39. What do we do with the minus 1? Okay, plus 1. So my 1.39 is now a what? A 2.39. And then if my x is over 2, that's a divide by 2. How do we cross that out? Multiply by 2. Remember, for your test, you want to make sure you're using the long version of the decimal. Okay, so in my calculator, I'm not going to type 2.39. I'm going to add 1 and then multiply that by 2. Okay, to make sure that my rounding doesn't come off, I got 4.77. Okay. You do not want to round until the very end. Okay, last one off this page we're going to do is number 27. What do I need to do first? Okay, divide that 3 out of the way. So I have ln of 5x equals 27 divided by 3 is 9. Now, I didn't type parentheses around the 5x. That's just a preference, so I'm going to put them. But if they're not there, remember, it's still in the log. It's the math. Okay, from there, how do I get rid of an ln, which is a log little e? Big E. Big E here, big E here. So remember, E and ln are inverses. They undo each other. So these guys are going to cross out. My 5x is going to carry down. And then do we remember where the E is on the calculator? So I'm going to divide by 5. Okay, it's right under where pi is. So in order to access the E, since it's blue, I'm going to do second divide by, and then up to the 9. Okay, make sure 9 is an exponent on the E. Okay, and it's a big number, 8103. 8103. Then from there, what do we do with the 5? Okay, divide by 5. And that comes out to 1620.62. Okay. All right, so the last 2 pages, I know this review looks kind of long. We're gonna do another little segment for like 10 minutes, let you work for a little bit. The last 2 pages will take no time at all, okay? So give yourself another 10 minutes to work. And then Mr. Gilland, if you'll just pause the video one more time, to give them a little bit of time before we move to that last page. All right, let's go ahead and turn to the last 2 pages here. Okay, last 2 pages, all that you're doing here are the log graphs and then the log rules. So we'll just run through a couple of these, kind of make sure that you remember how to do it. Let's start with number 33, please. Okay, the first thing that you should do when you see parentheses, okay, is you should be distributing whatever you have on the outside into that parentheses. So for example, my log 15, I'm just gonna leave it. But then what am I timesing in on the 10 here? Negative 3 times 10 is what? Negative 30 log A. And then what about the negative 3 times the negative 2 on the log B? Now that's a plus 6 log B. Okay, after we eliminate the parentheses, what numbers can I relocate to become exponents? The 30 and the 6. And I forgot to put my A here, so I'm just going to kind of squeeze it in. It's a little baby A. Okay. So the 30 and the 6 are going to jump up to be A to the 30 and B to the 6. And then from there, I'm going to sort my fraction based on whether the log is added or subtracted. Added logs end up where in the final answer? Top or bottom? Top. And subtracted logs end up in the bottom. So that means the 15 is going to go where? Bottom. 15 is going to go top. But a 30 is going to go bottom because it ended up with a minus. And then my B6 is going to go where? Top. Okay. But remember that you have to be a little bit careful because that minus, okay, needs to be distributed in before you can sort where stuff ends up. Okay. Same thing on number 35, please. I have a number on the outside of the parentheses. It's a 1/2. So I have 1/2 times 5. That would be 5 cut in half. And remember, if it's an even number, cut it in half, right? But if it can't, then just keep it as a fraction. So 1/2 of 5 would be 5 divided by 2, right? Okay, log A minus. My log B doesn't have anything in front. Then now I'm just going to put a 1/2 in front. So once I bring that 1/2 in, I'm going to apply it to the 5 first. In front of the log A, then in front of the log B. Then where can I move those numbers second? You can move them up to be exponents. So I'm going to have log A to the 5/2 minus log B to the 1/2. Okay, then from there, where is my A going to end up, top or bottom? A is going to end up on top. Where's B going to end up? Bottom. Now let's talk about the powers. B was to the 1/2. What is that the same as? Square root. And for your A, this one's a little bit tricky. The half is gonna turn into a square root, and the 5 is just gonna stay at the power. Okay? So remember that if it's a 5 cut in half, the half goes back to a square root, the 5 just kind of hangs. Yes, ma'am.
So whenever we first did this, for like the last one, at one point said that if it's, that sometimes it will be like a plus and then a minus, but then another plus, but both of those are on the bottom. So how do you, but this one, both of the pluses are on the top? I can't do it very well. So like sometimes it's multiplied on the bottom.
Let me give you an example of that. Okay. I'll come over and help you with that. Yes, ma'am. Yeah, that's fine. Yeah. Okay, bottom part of this. Okay, you are now expressing as expanded logs. That means that nobody wants to share a log. Okay, nobody wants to share. So if I'm doing, for example, number, let's do 37. I have a 7, an X, and a Y that are all in the same log. Okay, expanding means everybody gets their own. So are these currently multiplied or divided? They're all multiplied. Then I'm going to have ln 7 plus ln x3 plus ln root y. So step 1, you're going to take each of your guys, separate them into their own logs. Then step 2, any exponents up top need to drop down where? To the front. Okay, and remember, when we say to the front, we just mean to the front of that log, right? So I'm going to take my 3 from here, drop it down to the front. For my square root, what can I turn that into first? A half, and then drop it down to the front. So my final answer is going to be ln 7 plus 3 ln x plus 1/2 ln y. Okay, but remember, for an expanded log, nobody's sharing, and you shouldn't have any exponents or roots left over. Okay. All right, let's do one more from here. Let's do number 39. Okay, number 39, first question. I see that I have a 2 there in the very, very front, or in the very, very back on the outside. So I'm going to drop that 2 down to the front just to get it out of the way. So now I have this 2 log A6 okay, 2 log A6 over cubic root B. From there, how am I going to separate the log A and the log B, with addition or subtraction? Subtraction. So I'm going to have log A6 minus log cubic root B. Now, remember that originally, what number was outside of that? They both had a 2. So then I'm just going to kind of keep the 2 out here in the front. But if I'm splitting them up, if they were sharing the 2, then they both still need to be like a part of that process with the 2. From there, what can I do with the exponents up top? Drop them down to the front. The 6 will come down to the front here. And what will a cubic root turn into? A 1/3. Okay. And then from there, now that I have that 2 in the front, I can go ahead and just times that in. So my 6 log A, if I times it by 2, what is that now? That would now be a what? 12 log A. And then for my 1/3, if I times it by 2, what's 1/3 times 2? Now it'd just be 2/3 log B. Okay. So remember, 1/3 means divide by 3. So if I'm trying to times a 2 into that, I would just say, okay, then 2 divided by 3. All right, last page. We're gonna do one of each graph. This should be the easiest thing on your test. Okay, take a look for me, please, at number 41. Which way does a +5 move the parent function? Left, right, up, down? To the left 5. What about the -4? Down 4. So you're gonna go to the left 5, down 4. Remember that exponential functions do exponential growth. So you're gonna have a horizontal dotted line or asymptote that your graph can't touch through that point. Then remember, because your graph can't go through that point, do you remember that you start exactly one box above that origin? So if this is my center dot, I'm going to start exactly one box above. And then it's your growth graph, so it's going to grow on one side, flatten out on the other side towards the asymptote. For exponentials, it's a horizontal asymptote. What is the equation going to be for that line? Y equals what? That I can't touch, -4. Thank you. What is the domain of that graph to the sides? All real numbers. Good job. That's right. And then what is my range? Lowest comma highest. -4 to infinity. Very good. Now, one thing that you do want to be careful about is, can I actually touch -4? So what do I put, a bracket or a parentheses? Parentheses. Remember, infinity is the same. You can't get to infinity, so it's also. Okay. So use 41 to go back and do 40. Last one we'll do together is number 43. Okay, number 43, and oh, these are the same. Oh well. Okay, we'll do 43 and then just don't do 42 because it's repeat. Okay, which way do we shift a -2? To the right 2. What about the +6? Up. So right 2, up 6. And then remember, for a log, instead of your asymptote running across, your asymptote's going to run up and down. So it's going to be like this. And instead of stepping one box above the origin, do you remember which way we go? One box to the right. Very good. Okay. And then remember, it's still kind of the same shape, but it's growing up and away. And then down and towards. For my asymptote, it's a vertical asymptote. So what would the equation be? X equals or Y equals? X equals what number? 2. That means I can't touch 2. So my domain can't be all real numbers anymore. What's my domain? 2 to infinity. And then for my range, what's my range? Because I have one side down forever, one side up forever, so it'd be all real numbers. Okay. But let me remind you of one more thing. When you take your test, why is this the easiest section? Because you get a graphing calculator. So if you forget what it looks like, just type it in here and you can look at it, you know? Okay. All right. Good job. Y'all still have about 15 minutes. Let's see what we can finish up, please.